Hi to everyone. So welcome to another week. So this lesson is going to be your lesson for 26th of April. That's Monday. So this week again we'll be finishing this chapter 10 and we'll be starting chapter 11. Okay, again that's also algebra part. There is nothing. It's all algebra for you. Whatever is remaining chapter lessons for you. So before we start with chapter 11, first let's check the homework which we had to complete. That was on page 587. That was chapter 10 lesson 9. I asked you to do question number 2 and 3, and the next page question number 1 and 2. Okay, so quickly let's do this. They had asked you to graph the figure and find the length of BC. So they wanted you to find the side length, the length of BC, but before that we have to graph the figure and find out how the figure looks like. Only then we can count, or we can use absolute values, do anything, and then find the length. So first let's graph this. This is going to be A, which is 1 and 4. So as usual, this is going to be X. This is going to be the value for X. And this is going to be the value for Y. So 1 and 4 means X is here for 1. And 4 means it's here. You go up 4. So you draw a point here at this place. So this is going to be your point A. Okay, and then B is 1 and negative 2. So 1 here, again X is 1 and negative 2 means you need to go down because the negative numbers of Y is down. So 1 and negative 2, it is here. Okay, the next one is negative 3 and 2 for C. So negative 3 of X, this is X axis, so the negative 3 is here and negative 2 is again down. So we need to put a point here. Then we have negative 3 and 3 for D. So D is negative 3, again negative 3 and 3. So the next point for us is going to be here. Now all what we are going to do is we have to be joining the points, right? So let's join them. So before we join, first let me name the points so that we will not get confused. Okay, so this is going to be A. This was B, right? And this was C, and this was D. Okay, so let's join them. Use your ruler to join them straight. Now I'm using a different color so that the picture will be more visible. If you want also, you can use, no problem at all. So let me use this yellow. So first let me join from A to B. I think that's too light. I hope you guys can see, but let me make it a bit thicker. Let me take right so that it'll be more. Okay, so A to B. Okay, then B to C, from B to C, and then C to D, and of course we have to complete the picture, so we have to join from A to D also. So let's join from A to D. Now again, this is a trapezoid, okay, but we are not concerned about the picture now. We just need to find out the length of BC. So they want you to find the length of this from B to C. Now simply we can count to find out how many units, right? So from B to C, if you count, it is 1, 2, 3, 4 units. So you can say it's 4 units. But the lesson is about what? About finding the distance in a proper way. Of course, these are easy, but later on, when you are going later on, of course, you will have to know these lessons. So to do that, we of course have to find out the absolute value. Now, how do you find the absolute value? If they're asking the distance from B to C, so we are only taking these two coordinates, B and C only. Okay, so in B and C, first let's see what's the common number here. Common means which is the same number in B and C. It's 1 and negative 3 and negative 2 and negative 2. So for negative 2 and negative 2, we don't need to do anything, because if you find the absolute value, that's the same, negative 2 and negative 2. So we are concerned only with 1 and negative 3. So what's the absolute value of, what is the absolute value of 1 going to be? So I'm taking this one from B, okay? So the absolute value of 1 is going to be 1. Fine. And the next one, which number are we going to take from this ordered pair? Are we going to take -3 or -2? We'll of course take -3 because -2 is in both places. So let's take -3. What's the absolute value of -3? It's going to be 3. Now, remember on Thursday we learned that if they are on different quadrants, see, B is in quadrant 4 and C is in quadrant 3. So if they are in different quadrants, so we need to add them. But if they are in the same quadrant, then we will subtract them. But here, the quadrants, I hope you all remember what are quadrants. This is quadrant 1, this is quadrant 2, this is quadrant 3 and 4. So because they both are in different quadrants, so we will add them. So let's add them. That's going to be 1 plus 3 equals 4 units. So in the answer, you will be writing 4 units here. Just have to write 4. Okay, fine. Moving to the next question. So next question is again the same. It's A is -1 and 4. So -1 is here and 4 is up here. So draw a point. And then 5 and 4. So 5 and 4 is here again. Then 5 and 1 is for C. 5 and 1 here. Okay. And then -1 and 1. So -1 and 1. So this is a rectangle as you can see, right? So they want you to find the length of B and C. But before that, first let me write down the points. Okay, this is going to be A. And this is going to be B. This is C. And this is D. Hopefully you all have done the same way which I am doing. So let's join the points now. Again, I'll choose another color so that it will be more visible to you. So we will join A to B. Do make sure it is straight. Okay. Then again, B to C. And then C to D again. And then because of course we need to complete the figure, we will join from A to D. Right? So it's a rectangle. Now what are we going to find? We have to find the length of BC. So they want us to only find from B to C. So simple, we can count, right? 1, 2, 3. So the answer is going to be 3 units. But we have to do it in a proper way. So of course we have to be using these two coordinates of B and C. Now B is 5, 4, C is 5 and 1. So which numbers are we going to use to find the absolute value? 5 and 5 are the same. Right? So we will be finding only the absolute value of 4 and 1. So what's the absolute value of 4 and 1? The absolute value of 4 is going to be 4 and the absolute value of 1 is going to be 1. So now make sure, are they both in the same quadrant or different quadrants? Are they both in the same quadrant or different? They both are in the same. So if they both are in the same, that means we have to subtract them, right? So 4 minus 1 equals 3 units. So your answer here is going to be 3 units. Okay, so why did we subtract? Because they both are in the same quadrant. Here, why did we add them? Because they both are in different quadrants. Okay, so quickly let's move on to the next question. That's question number 1 and 2 on the next page. The coordinates of points M, N, and P are M, N, and P. What coordinates for point Q makes M and PQ a parallelogram? Now again, I'll be using those same quadrants as the coordinate plane, okay, for the one which I used for the previous one. So okay, so I have to get this coordinate plane because they did not give us the coordinate plane. Now you can use any coordinate plane which is given in your book, the previous one also, because we just need a reference to find out what the answers are. So they had given us some coordinates, so we have to draw them, only then we can get the other to make a parallelogram. So first let me draw the coordinate for M, that's -2 and 3. So -2 and 3 is here. Okay, this is going to be M, and N is 4 and 3. You please follow the question which is in your book. So this is 4 and 3, and P is 5 and -1. So 5 and -1. Now the question was, it is a parallelogram, right? What is the coordinate for Q? So first let's join these 3 points, and then let's check what the how the parallelogram is going to look like, and then let's find the coordinates for the other one. So this is going to be MN, and then this is going to be P, and we have to find the Q. So before that, first let's join them. Again, I'm using another color so that it will be clear enough for you all. Okay, so let me join from M to N first. So M to N, then N to P. Okay, now they said it is a parallelogram. So you know how a parallelogram looks like. To join the other side, we need to check from here till here how many points do we need to move. So if you see that, you can see from here, see it's going to be like, we have to draw the other side. So from here, see, you have to come 1, 2, 3, 4 down and 1 to the right. So to get the next point, which is Q, you have to follow the same pattern. So here, how many did we move? It's 1, 2, 3, 4, and then 1 to the left. 1 to the right. So same we will do here. It's 1, 2, 3, 4, and 1 to the left, 1 to the right. So this is going to be our point Q. So once you draw that, your parallelogram is going to look complete. So which is going to be point Q? This is going to be point Q. Okay, so what are the coordinates for this point? The coordinates for this point are -1 and -1. So you have to write in the answer space as -1 and -1. How did we get -1? We need to join the other corner. We need to join the new corner. So to find that, you have to follow the same pattern from here to N to P. So from N to P, we need to move 4 down and 1 to the right. So to get point Q, because they said it's a parallelogram, you know how a parallelogram looks like. So we have to use as 1, 2, 3, 4 down and 1 to the right, and join the point, draw the point there and complete the parallelogram and get the coordinate. Fine. Okay, moving to question number 2. So question number 2 says, Dirk draws quadrilateral RSTU with vertices R. Which is the best way to classify the quadrilateral? Now the question here is simple. What they are telling you, they are asking, first let me open the question. Okay, where is the question? Okay, so the question for the next one is okay. The gross quadrilateral RSTU with vertices R is -1, 2, S is 4, 2, T is 5 and -1, and U is -2 and -1. Which is the best way to classify the quadrilateral? So here nothing, you just have to draw the points and then say what kind of quadrilateral is drawn. That's all. You don't need to find the length, sides or anything. So let's draw and check what kind of quadrilateral are we getting. Okay, so I'm just quickly drawing the points. R is -1 and 2. So this is going to be -1 and 2 here. Okay, this is going to be R. And then S is 4 and 2. So that's going to be here again. Okay, and then T is 5 and -1. So that's going to be here. 5 and -1. U is -2 and -1. So -2 and -1 is going to be here. So let's join and check whether what kind of quadrilateral are we getting. Fine. So I think this color is too light. Let me take this. Okay, so first from here to here. Now you of course need to write the names of the points. So this is going to be R, this is S, and this is T, and this is U. So do write it. I'm just joining the quadrilateral to check what kind of quadrilateral are we getting. So as we join, we can see clearly that this quadrilateral is a trapezoid. So in the space given, you have to write the answer as trapezoid. The only problem with this lesson was the quadrants. To draw the graph, to draw the picture, the graph was not given, that's all. But you can use any graph which is given extra, like which is given in different questions, and then find out. So this was the answer for question number 2. So what kind of quadrilateral is it? It is a trapezoid. Okay, so this is going to be a trapezoid. Okay, so quickly let's move to today's lesson. So today we are going to be starting the new chapter. That's chapter 11, lesson 1, page number 597. Now, this lesson is all about your imagination and your thinking. Okay, now why am I saying your imagination is needed in this lesson? Because you are going to be drawing the picture like in an open way, which they are asking you to. Okay, now before we start, but let me first tell you, you're going to be learning about 3-dimensional figures and nets. Okay, now all of us have heard of 3D, right? 3D movies, 3D cartoons, 3D games, all these things we have heard. Now, what does this 3D means? 3D means 3-dimensional, which means you can look at a picture from 3 different angles. Okay, that's why we say as 3-dimension, 3D. Now, what does that mean? Look at this picture. Okay, 3 different angles. I said 3D means you can see from 3 different angles. So what are the 3 different angles you can see? So if this looks like a cheese slice. Okay, that's what came to my mind when I saw this first. It's looking like a cheese slice. That's my imagination. You can have your own. So I can see the top part of this picture. Okay, then I can see the side. Also, I can see another side. I cannot see what's behind, I cannot see what's under. Okay, so in this picture, okay, I can see the length, right? I can see how long it is. I can see the width, how much is the width, and I can also see the height. So in the dimension, in the figures, if you can see the 3 things, that's the length, width, and height, then it is called as a 3-dimensional figure. Now, base, all of us know. Now, in this lesson, you need to remember base means the top part as well as the down part. Now, in this picture, base is going to be this as well as the down part. Okay, and then vertex are the corners of the picture, of the diagram, or of the figure. We'll be using the word figures more in this lesson. So vertex are going to be the corners of the figure. Edge is going to be these lines around. Okay, and lateral face is what we can see in a figure. Like if you take a triangle, what can you see? What on up can you see is called as the lateral face. I know it's new for you, so of course it will be a little bit difficult to understand, but when you start solving the questions, yes, you can easily do it. Fine. So a solid figure is a 3-dimensional figure because it has 3 dimensions. So what are the 3 dimensions? Length, width, and height. Solid figures can be identified by the shapes of their bases, the number of bases, and the shapes of their lateral faces. Now, always solid shapes, when we talk about solid shapes, okay, how are they named? They are named based on their, what kind of figure does the base have, and the number of bases, and the shapes of the lateral face. Okay, so in this is called a triangular prism. Why is it called a triangular prism? If you look down, the base is a triangle. See, the base is a triangle, so it is called as a triangular prism. Fine. Now most of us, not most, everyone has seen pyramids. As you know, Egypt is very famous for the pyramids, right? Now why are they called as pyramids? Now in pyramids also there are different kinds of pyramids. It's not only all the pyramids are same. Some pyramids have the base as triangle. So those pyramids, we call them as triangular pyramids. The one which we see in Egypt, the base of those pyramids are square. So we call them square pyramid. Okay, so based on the base, we name these solid figures. Fine. So before we start, first you go and check what the dog has to tell you for today's lesson, and then let's continue the work. Okay.
Hello, the beach was very crowded yesterday. Everyone was having a great time. One of my family members bought a snack at the snack stand, and it came in an interesting package. Look under the blanket to see the package. Check out the shape of this box. It's different than most I've seen. The sides are made of 2 triangles and 3 rectangles. I wonder if it has a certain name. Come on, let's see what we can find out about identifying the names of solid figures. Let's explore how a net can be used to represent a solid figure.
Okay, now this is the same question as
To find the answer, first identify the solid figure.
It's the same as the question which is in your book. That's going to be page, the same page which I was showing, page number 597. It's the same question they are solving. Okay, so you will of course need to follow what they're saying, and then let's come back and then do the question. So please do concentrate and then watch the video.
Then draw the matching net. Let's unlock this problem. The cereal box is a solid figure with 3 dimensions: length, width, and height. Solid figures can be identified by the shapes of their bases, the number of bases, and the shapes of their lateral faces. Let's identify the bases of the cereal box.
Okay, so everyone has these kinds of boxes at home, right? The cornflakes boxes or any chocolate boxes. When we buy the boxes, looks like this. So this is a cereal box. Okay, now next time when you get a cereal box, just open up and check how is the box made. Then you will get something called a net. Net is, in simple words, when a solid figure is opened up, how the picture looks like is called the net. So that's what they want you to do in this question. They want you to draw the net for this figure. Now if you have got a box like this in your home, please pause the video here, go get it, and then first open it and check how the net of the box looks like. Else you can follow what's here. Now they're asking you about the bases. Now as I said before, base is going to be the top part and the down part. So how do you think this bases are going to be?
The cereal box has 2 congruent parallel bases, the top and bottom of the box. The bases are rectangles. Using this information, let's identify the solid figure.
Okay, so the base is going to be 2 rectangles, right?
The cereal box is a rectangular prism, since it is a solid figure with 2 congruent parallel bases in the shape of rectangles. Its lateral faces are rectangles. Let's identify the other 2-dimensional shapes that form the cereal box. What are the front and back lateral faces?
So now we know what's in the top and bottom. So first, then let's see what is in front and behind the box.
The cereal box has front and back faces that are rectangles. What are the left and right lateral faces?
So this was the front, and then let's see what's in the left and right.
The left and right faces are also rectangles. Now, let's draw a net for the cereal box using the shapes that make up the solid. A net is a 2-dimensional figure that can be folded into a solid figure. Let's first draw the front and back lateral faces on the net.
So first start by drawing the front and the back. Whenever they ask you to draw a net. Net means when you open up this box, how it will look like. That's called a net. So always when drawing a net, first open up the front and back.
The net shows the front and back faces of the cereal box. Now let's draw the top and bottom bases on the net.
So first you have to draw the front and back. So you know the front and back are two rectangles. Now then draw the top and the bottom. So that will be like
this. The top
this.
and bottom bases of the cereal box have been added to the net. Let's draw the left and right faces on the net.
So once you have drawn the top and bottom, then draw the left and right.
The left and right faces of the cereal box have been added to the net. The net is a two-dimensional representation of the cereal box. This is one way to draw the net. So the designer can use the net to show the placement of information and artwork on the cereal box.
Okay, so I hope this part is clear for you. When they are asking to draw a net, nothing, just first check what is the base, what are the bases, the up and down. So draw them separately, how they're looking. So from the box you can see that they are rectangles. Then check the front and back. How are they looking? They are also rectangles. Then go to the left and right. How are they looking? They are also two rectangles, but thinner ones than the front and back, right? Now, how to draw the net? Start by drawing the front and back first. So this was the front, this was the back, and then join the top and bottom. So draw the top and bottom bases together, then join them with the left and right faces. You will get the net for what they have asked for. And then why is this called a rectangular prism? Because the base is a rectangle. So the bases are rectangles. It's called as a rectangular prism. Okay.
Let's explore the net and identify and sketch the solid figure it could represent. Identify and sketch the solid figure that could be formed by the net.
Okay, now before doing this question, I want you all to do this question first. That's the first one. So let's start doing this, unlock the problem by ourselves. Already it's the same as I told you. So first let's see. How many bases were there for this box? For this box, how many bases? There was one up and one down. So you need to be writing here 2 bases. Okay, so right there, quickly write there 2. Fine. Then are the bases congruent? Congruent means are they equal? Means of course they both are having the same, right? It's not one is small, one is big. They both will have the same. So are the bases congruent? Yes. Congruent means equal. What shape are the bases? What shape was the bases? This is a base. So from this base, what can you say? It is a rectangle. So the bases are rectangles. Fine. Now, is the cereal box a prism? A prism, see, they gave you already the definition. It's a solid figure with 2 congruent parallel bases. Its lateral faces are rectangles. It is named for the shape of its bases. So if a figure has 2 congruent parallel bases, for example, like this, the upper part is equal to the down part, and the lateral faces, that's the faces which we can see outside, are rectangles. It's called as a prism. Now, is the cereal box a prism? Of course it is. So you write yes. What shapes are the bases? Again, they're asking the same question. What is the shape of the bases? What are the shapes of the bases? It's rectangles. So depending based on the base of the box, what is this? What is the name of this solid figure? The base is rectangle, so it's going to be a rectangular prism. Okay, the base was triangle, it's going to be a triangular prism. Fine. A net is a 2-dimensional figure that can be folded into a solid figure. So make a list of shapes you will use. What did they use for the top and bottom bases? Remember in the picture, in the video, what did they use? They were rectangles. Okay, then what was the left and right faces for that? They were also rectangles. You do remember what was going in the video, you will do this easily. What was in the front and back faces? They were also rectangles. Now draw the net using the shapes you listed in step 1. One possible net is shown. So this is one of the possible net. Now what do they mean by one of the possible net? You can draw this net in another way too. How can you draw? Now this is the way they drew. You can first draw a triangle like this, and then all the remaining parts you can join with them. Okay, there are many ways to draw a net. It doesn't need to be the same way which they have drawn you have to draw. No, there are many ways to draw. Now for example, instead of these two sides coming here, you can also put the two sides here. It doesn't matter. Anyhow, when you fold it, you will get the same rectangular prism. So this part I don't want you to do because you'll be drawing so many later. Now I want you to concentrate on this. Okay, now first let's see this. Identify and draw a net for the solid figure. So again, they're asking you to draw a net. Describe the base of the figure. Now look at the base of this figure. What is the base here? That's a triangle, right? So just write there triangle. Now describe the lateral faces. Lateral faces is what you can see from outside. So what are the faces you can see from outside? What kind of shapes can you see from outside? They're also triangles, right? So the lateral faces are also triangles. The figure is what was the what were the conditions for prism? Prism should have rectangular faces, but this doesn't have rectangular faces. So what are we going to name this as? This is going to be a triangular pyramid. We know it looks like a pyramid, right? But it depends on the base, what kind of pyramid it is. See, now the base here is rectangle. So this is called as a rectangular pyramid. But here, the base is a triangle, so it's called as a triangular pyramid. How do you know it's a pyramid? A pyramid's lateral faces are all triangles. Like prism has all rectangles, a pyramid has all triangles as lateral faces. Okay, so shapes to use in the net. How is the base going to be? Base is going to be a triangle. Okay, how many lateral faces? Lateral faces of a pyramid. Just think how many faces will lateral faces, and means how many triangular faces will the pyramid have? It will have 4 triangles. So that's also going to be triangles. Lateral faces means what we can see from out are also triangles, right? So how are you going to draw the net? Now again, to draw the net, of course, I will have to open up the paint. So I'll open the paint program. Okay, so now we know the base is going to be a triangle. So let's start by drawing the base. Okay, so this is going to be your base. Now, what were the lateral faces? Lateral means the side faces. How many side faces will the pyramid have? It will have, because the base is 3 triangles, so you are going to be drawing lateral faces as pyramids too. So you'll be drawing like that. I'll show you. So this is going to be one face. Okay, this is going to be 2 faces for the pyramid, and then this is going to be the 3rd face for the pyramid. So this is the net which they want you to draw. Okay, which means if you fold along these lines, you will get a pyramid. This is what the net is about. So the net for the triangular prism, a triangular pyramid, is going to be like this. Start with the base. Okay, so you draw the base. Base was a triangle, and then from the base, draw triangles each. How many faces will it have? It will have 3. So you just draw 3 triangles to show the net. Clear? Okay, so let's move on to the next video and check. Now this is similar to example number 2. So please concentrate on what they are telling in the video and then complete it side by side. Okay.
The solid figure that could be formed by the net. Let's begin with a triangle.
So here they want you to identify and sketch the solid figure. Here they gave you the net. So you have to draw the figure now. So they are showing you how to draw the figure, the solid figure. Now when you see, you can see that there are two triangles and three rectangles, but one of the rectangle is smaller and two of them are of the same size. So first see how they are going to draw.
The sketch shows one triangle. Now let's add the other.
So because there are two triangles, but they are not together, they are a little bit far away. So see how they are drawing when another triangle is far away. Give some space and then draw.
The sketch now shows two triangles. Let's connect the corresponding vertices of the triangles using line segments.
So now we need to join them, right? You cannot have two separate triangles. So to join them, you just
Let's
draw them
continue
lines.
connecting the corresponding vertices until a solid figure has been formed. Let's finish connecting vertices.
So they're just joining the vertices, that's all. From one corner to the other, this corner to this, and from this corner to this.
The sketch shows the solid figure that could be formed by the net. Let's use dotted lines to represent the unseen edges. So is the figure a pyramid or a prism?
Okay.
A pyramid has one base and lateral faces that are triangles. The sketch of the net shows two triangles as the bases of the figure and rectangles as the lateral faces. So the figure cannot be a pyramid. It's a triangular prism. Its bases are triangles and the lateral faces are rectangles. The figure is named a triangular prism for the shape of its bases.
Okay, so let's complete the concern question for this. Example number 2. Fine. So the net has only how many triangles? The net has only two triangles. So it cannot be a pyramid because a pyramid has only, okay, so it cannot be a pyramid. So the triangles must be the dash for a dash. So triangles must be the bases. Because there are two triangles, they are going to be the bases for a triangular prism. Remember, for prism we said the lateral faces must be rectangles. So the lateral faces here are rectangles, only the bases are triangles. Fine. So let's do question number 1. Okay, so what is the base for this question? I mean, for this figure, the base given here is square, right? It's not rectangle. You have to be very careful when you're looking at the picture. So it has to be square. Okay, how many lateral, what are the lateral faces? Lateral means what you can see. What are the faces you can see? What shape are they? They are triangles. So what is the name of this figure? It's going to be a square pyramid, right? Or yeah, it's going to be a square pyramid. Why did we say it's a square pyramid? Because the base is a square and then we have the triangles as lateral faces. So if any figure has triangles as lateral faces, then it's called a pyramid. How do we name it? Based on the base. So the base is a square, we call it as a square pyramid. Now we need to be drawing the net for this. So to draw the net, of course, I'll have to go back to the drawing program. Okay, so let's draw the pyramid now. Fine. So what was the base? Always start with the base. Base was a square. So let's draw a square first. Okay, this is a square. Then what were the faces? There were 4 lateral faces because it's a pyramid. So pyramid has how many, like the faces are all triangles. So simply just draw triangles from the sides. This is 1. Make sure that they are equal. That's 2. That's 1 triangle. So this is going to be the second triangle. This is going to be the third triangle. And this is going to be the fourth triangle. Make sure that you draw it a bit long. So this is going to be the net for your square pyramid. Easy, right? Only that you need to understand the picture and then imagine how it looks like when you open it up and then draw it. Okay, so let's move on to question number 2. Now this one, first we need to check what's the base here. Base is a square, right? Then the lateral faces are also squares. So if the base is square and the lateral faces are squares, so let's write it down so that will be easy for us. Base is square, okay? Then lateral faces are also squares. Fine. So what is the name of the figure going to be? Can we say it's a pyramid? No, we cannot say pyramid because the lateral faces are not triangles. Only if the lateral faces are triangle, it's a pyramid, but here it's a square. So what name can we give for this? If it's not a pyramid, it's a prism. Okay. Now, of course, this is a prism, but what kind of prism is it? We can now just think, what does this picture look like? It looks like a cube, right? Cube, you know what a cube looks like a box, an equal-sided box. So the name of this is going to be a cube, or you can even say this as a rectangular prism. Now, we don't usually say it's square prism because square prism, in other words, is cube. Okay, because the base is a square, and if the base is square, of course, if all the other sides are looking the same, then that's going to be a cube. So either we say such pictures as cube or we say them as rectangular prisms. I know you might say, now teacher, the base is not a rectangle, but if you notice it properly, all the sides are equal. So any solid figure which has all the sides similar is called as a cube. Fine. So better you write a cube, else you can write it as a rectangular prism. So now let's draw the net for this. Now, as you know, base is a square. Okay, now the lateral faces are also squares. So we need to, how many lateral faces will a cube have? A cube, now if you have a cube, fine, you can just look at it. If there is no cube in front of you, you can just take any box which is complete and check how many faces do they have. So base will be 1, and other than the base there will be 5 more faces for the box. So let's draw that. Okay, let's go back and draw. So first, let me start by drawing a base. Base is going to be a square. Okay, now I'm going to draw the lateral faces. So how many lateral faces did that have? It's all squares. So I will join the squares. Right? Just make them equal. Make sure that they are equal. Fine. So this is going to be the second face, and then we'll have to draw a third face because a cube has all 6 equal sides. So this is going to be your third lateral face. Fine. Now either I can start from here and here, or I can go on drawing 4. I will draw 4 like this because a cube has 6 sides, right? And then I can draw 1 up here and 1 down here. So that will complete the 6. Else you can draw 1 up here, that we are drawing the sides now. These are the 4 long ones, fine? So for the side 2, so I can draw 1 here, 1 here. Anywhere you can draw 2, it doesn't matter. There is no hard rule for nets that it must be like this. So I'm drawing it here. So this is the net which is going to be for your cube. So it's nothing but the base is a square, and then you will draw 5 more squares to complete the cube because a cube has 6 faces. So we need 6 faces for the cube. So here we have drawn 6 squares. Fine. Okay, so let's move on to question number 3. Identify and sketch the solid figure that could be formed by the net. Now, I'll make you write the name, okay? You don't need to draw the picture. So let's first find out what kind of solid figure is this. Now, there are 4 triangles, 1, 2, 3, 4. So which means the base is a triangle and the face is also triangles. So if the base is a triangle, what is that going to be? It's going to be something and then pyramid, right? Why pyramid? Because the base, the faces are triangles. So the faces are triangles, so it's called the pyramid. Now the base is also triangle. So what do we call the figure as now? It's called as a triangular pyramid. The base is triangle, so triangular pyramid. Now here, how many do we have? 1, 2, 3, 4, 5, 6. Again, there are 6 squares. Now 6 squares is what we drew in the previous net also. So if the base is a square and the lateral faces are square, of course it's going to be a prism, right? Now if it's a prism and all the sides are equal, that's all are squares, we call that as a cube. Easy, just that you need to identify them, that's all. Now what is the name of this going to be? The name of this is going to be, look at the base, it's triangle. Okay, now are all the faces triangles to keep them as pyramid? No. If all the faces are triangles, then it's a pyramid. But here, see, this is a rectangle. So this is not going to be a triangle, that's going to be a prism. But what kind of prism? That's going to be a rectangular prism. Fine. Now this one. Again, the base is a rectangle and the faces are not triangles. They are squares and rectangles. So what kind of solid figure is this going to be? Look at the base. Start with the base. So that's going to be a rectangular prism or pyramid. Prism. Because pyramids have all four faces as triangles, but here there is nothing. Okay. Question number 7. The lateral faces and bases of crystals of the mineral galena are congruent squares. Congruent means equal squares. So what is that? We have come across many questions this kind. So the face is also square and the base is also square. So if the base and the face are all squares, what is that called? It's called a cube, because we have already done that. Okay. Now, I don't want to do any more questions for this except question number 10. Okay. Sasha makes a triangular prism. Now, this is the keyword here, triangular prism from paper. So, triangular prism means the base is triangle, but the lateral faces are not. Okay. The bases are going to be what? The base of this triangular prism is going to be triangles. Okay. The lateral faces, are they going to be rectangles, squares, or triangles? For a prism, it's going to be triangle. Now, if it's triangle, it's going to be a pyramid. So it's going to be rectangle. Hope this lesson is clear for you. Okay. So what I want you to do is you have to do question number, identify and draw a net. Okay. We have done all the similar questions. Fine. So you will of course do question number 2, 3, 4, 5, 6, and the next page question number 1 and 2. Okay, so until I meet you all in the next video, keep doing your homework and enjoy yourselves and keep yourselves safe and take care of yourselves.